Welcome to College Algebra Trig, Semester 1, Final Exam Review, Part 3. Find the coordinates of the maxima of f of x equals negative x squared minus 4x plus 4. So first I have to recognize what type of polynomial is this. The highest exponent, or the degree, is squared, so it's simply a parabola. And if you think of a parabola, it's either going to open up or down. My leading coefficient is negative, so I know it's opening down. And they want that maximum point, which we know as the vertex. So the formula for the vertex is x equals the opposite of b over 2a. And of course, b is going to be the term in front of your x, and a is going to be the term in front of your x squared, which in our case is just negative 1. Okay, so as I plug those in, the opposite of negative 4 is 4, and 2 times a, which is negative 1, you end up with negative 2. They want coordinates, so I now have to plug in negative 2 wherever there's an x. So I can say the y, please excuse that, the y value equals negative, and x is now negative 2, right? So yes, you have to have a negative on the outside. X is negative 2 squared minus 4, it's a minus, not a plus, times x, which is negative 2, plus 4. Oops, I hit the wrong button, sorry. It's a little sensitive, so bear with me here. My apologies. Now, when I do the math here, negative 2 squared is 4, but then it's a negative, so negative 4 plus 8 is 4. 4 plus 4 is 8. So the coordinates end up being negative 2, comma 8. And I apologize for the sloppiness. Again, writing on this iPad is not as easy as writing on the smartboard, so bear with me. Okay, number 14 says, Chemco Manufacturing estimates that its profit P in hundreds of dollars is P equals negative 4x squared plus 40x plus 3, where x is the number of units produced in thousands. How many units must be produced to obtain the maximum profit? So again, the key word here is maximum, and again, the highest degree here is a 2, which again makes it a polynomial, okay, which means I'm looking for the vertex. So again, I'm going to find the x value, same as above, negative b, or the opposite of b over 2a. This time, my a value happens to be negative 4, and then my b value happens to be 40. So when I do this, the opposite of 40 is negative 40 over 2 times a, which is negative 4. You end up getting negative 40 divided by negative 8, which happens to be a positive 5. Now, what are they asking me to find again? Because it didn't say the coordinates. It says how many units must be produced. So how many units to obtain the max profit? Well, x is the number of units produced, so I have that. But here's the part you have to read. It's in thousands. So the maximum occurs when x is 5, but it's not 5, it's 5,000. Okay? Let's look at number 15. Identify the end behavior of the graph of the polynomial function. When we're talking about end behavior, there's two pieces you need to know. You need to look at the degree and the leading coefficient, which I'll explain those in a minute. And we're actually going to start with the leading coefficient. Okay, here's the leading well, first you find the degree, which is the highest exponent. In our case, that's 4. Okay, the number in front of that variable is going to be your leading coefficient. So my leading coefficient in this case is negative 3. There's two things they can tell you. If your leading coefficient is negative, or if it's positive. Okay? If it's negative, your right end goes down. If it's positive, your right end goes up. So when we look at our leading coefficient, which in our case is negative 3, negative tells me my right end behavior goes down. Okay? Then we're going to look at the degree, and the degree tells us two things. If it's even or if it's odd. If it's even, the left goes same way. Same way as what? Same way as your right. So let me make more room down here. So we had erased that our right end goes down. Okay, if it's odd, your left goes opposite. So my degree is 4, which is even. So my left also has to go down. So I don't know what's happening in here, but I know both ends go down. So they may ask you in that way, or they may ask you in terms of limits. If they ask you in terms of limits, let me help you. One will say the limit as x approaches negative infinity. Remember, negative infinity refers to the left side of f of x. So they're saying as x goes to negative infinity, as it goes left, which way is it going? Mine is going to negative infinity. They may say to you, what is the limit as x approaches infinity? When it says positive infinity, that's when x goes to the right. So as I follow my graph out to the right, what's happening to the f of x or the y value? It's also going down to negative infinity. Please pause this video if you want to write this down, as I will be erasing and moving on to 16. Okay, as I erase, let's read 16. Write the equation of a polynomial function that has zeros at 2, 1, and negative 1. So what do they mean by this? Well, here what they're doing is they are actually giving you the answers. They're telling you the zeros, roots, solutions, x-intercepts, they all mean the same thing. They're telling me that, I'm doing this right up here just in case you're a little confused. They're telling me that x equals 2, x equals 1, and x equals 1. Now if you think about working backwards, what if I wanted to set these equal to 0? I would subtract 2 from each side. So I'd have x minus 2 equals 0, x minus 1 equals 0, and x minus 1 equals 0. Now, if you think about it, usually when we factor it and they're all set equal, we split them up. We're going to go backwards. We're going to put them all together because they all equal 0. I'm just going to say x minus 2 times x minus 1 times x minus 1 equals 0. Okay, so what do we have to do now? Well, we're going to FOIL, or double distribute, however you want to think of it. And I'm only going to look at the first two to begin with, the first two binomials. So x times x is x squared. X times negative 1 is negative x. Negative 2 times x is negative 2x. And negative 2 times negative 1 is a positive 2. Now I haven't done anything with this third polynomial yet. And it's actually a binomial, excuse me. I'm going to leave it for now. And I'm going to go ahead and combine like terms on this orange piece here. And I'm left with x squared minus 3x plus 2. And then bring down the binomial in green, x minus 1. Okay, we got to do it again. How am I going to do this? This time, everything in the first trinomial gets multiplied by everything in the second binomial. I'm going to come and put this right up here. Okay, so x squared times x is x to the third. X squared times negative 1 is negative x squared. Negative 3x times x is negative 3x squared. Negative 3x times negative 1 is a positive 3x. 2 times x is 2x. And 2 times negative 1 is negative 2. Okay, so if I just combine like terms with these, I'm just going to highlight them for you. I have negative x squared minus 3x squared. And then I also have positive 3x plus 2x. When I combine those like terms, here's my final answer. X to the third minus 4x squared plus 5x minus 2.